I'm Alexandre Bonvin. I'm a professor in the chemistry department at Utrecht University in the Netherlands. Within the GANANA project, I'm leading the life science activities, and these include two main software developed in Europe, GROMACS, which is used for molecular dynamic simulations of biomolecules, and HADOC, which is used for integrative modeling of biomolecular complexes. Both software have a very large user base around the world and particularly in India. And within GANANA, we're going to improve those software, both in terms of performance, and this is mainly focused around the GROMACS software, but also in terms of application domains. So we want to develop also new tools, AI-based methods to better model interactions between biomolecules, and develop workflows that will facilitate the modeling of immune complexes in particular. The developments within GANANA in the life science area around the two software that I mentioned will enable us to simulate larger systems, will enable us to simulate for longer times the behavior, the dynamic behaviors of biomolecules. And this is highly relevant because biomolecules are the core of everything what's happening in our cells. So they dictate the fate of cells, they dictate communication within cells, in between cells, and miscommunications of problems with those biomolecules is at the origin of disease very often. So by understanding how they work, we will understand better the origin of disease in some specific application, and then we can also intervene, take the first steps toward the development of drugs, therapies against disease. But this is very much on the research side of drug development, because the drug development process itself is a very long pathway. It takes 10 to 15 years until a new drug comes on the market. But the research activities within GANANA will enhance all the research done in a few years, basically in the first few years of the development of drugs on the long term.